Our distinguished speaker today is Melvin Greer, and he will speak for about 30 minutes and then take your questions at the end. And we really do encourage your participation. It's a forum, it's an exchange here. And as we kind of build this whole community around government analytics. We are also live streaming the event. So when you guys want, on the live stream portion of this, want to enter questions, there's a box below the video where you can do that. We also encourage you to tweet, and you can do that using the hashtag GAB forum. So a recording of the event will be posted both to REI's website as well as our JHU website about 24 hours after the presentation today. So thank you again for taking the time from your schedules to make it out here this morning. Enjoy your breakfast, and very much the speaker, but I'm going to turn it over to Jeff now to introduce him. Thanks.
Thanks so much for having us, Kathy. And I really do want to extend our appreciation to Johns Hopkins. I think Johns Hopkins has a great and a much growing program in government analytics. So those who are interested in studying and advancing their skills, those who are interested in hiring recruits who have some great skills in analytics, I would encourage you to contact Kathy. And I want to send a shout out over the web to Jen Bachner, who is the director of the program here in government analytics, but is unfortunately unable to be here because of recent surgery. Also, I want to describe the entire purpose of this event is to strengthen the government analytics community here in Washington. And that means there's a good chance that if you turn to your left or turn to your right, there is someone who has had some different experience than you. And they may know some things that you would find valuable and want to learn from them about, and vice versa. So this is an opportunity, hopefully, for you to not only kind of learn from our speakers about the particular topic at hand, but also learn from each other. With that in mind, I'd like to encourage you to ask questions, because I think it'll be a more interactive and interesting discussion. I'd also like to encourage you, if you say, hey, you know, there's another topic or another agency or another person I'd like to hear from at an upcoming event, please do email me. My card is in the contact information is in all the folders you have. If you're looking at this on live stream, my email is jmyers@reisystems.com. REI is pleased to sponsor these events. We do work in a variety of ways with analytics customers, primarily throughout the federal civilian agencies, but starting with a little bit of state and local as well. And we really are interested in, again, kind of extending the focus on analytics. One last plug, which is in February, I believe it's February 20th, we'll have the next one of these government analytics breakfasts, and that will include senior representatives from the Security and Exchange Commission, who will speak about how SEC uses analytics to target some of their enforcement activities, and also to do some monitoring and some kind of information gathering to help inform some of their policy setting activities. So I hope you'll be able to join us for that, if not in person, then again via live stream. And with that, actually Kathy's kind of already introduced Melvin Greer from Intel, the Chief Data Scientist for the public sector. So please join me in welcoming Melvin Greer. Thank you for coming, Melvin.
Okay, so I'm going to try to stay over here, although it may not work too well. I want to thank Kathy from Johns Hopkins and Jeff from REI. They were very gracious. I understand I'm one of the first non-government speakers to be here, so I'm really happy to join you. You have my bio, but I'm going to share a few tidbits about me that might be interesting to know as we go through this discussion. First, I'm married to a woman who's a great chef. So clean food is a big deal for me. And I actually serve as an adjunct at 2 universities. So I'm an academician as well, so I really don't need slides. I can talk to you about 3 hours and give you a test without any slides. I joined Intel about 2 years ago. Prior to that, I was with Lockheed Martin. I was a senior fellow and vice president for advanced research. And I really enjoy both of the jobs that I had and the one that I have now. The goal of the discussion that I have with you today is give you a sense of what's really happening with respect to artificial intelligence in the public sector, and give you some ideas to think about as you start on your journey of adopting data science and artificial intelligence. We'll talk a little bit about the ethical, legal, and societal implications associated with that adoption. And in a non-marketing way, I do want to share with you why Intel even has a chief data scientist for public sector Americans. Well, why do we have that? And I'll give you some idea about why that is and what we're doing in AI and data science. So again, I'll take questions at the end. I'll try and get through this discussion in about 30 minutes or so. So we're at Johns Hopkins. We can't really have a discussion about artificial intelligence at Johns Hopkins without talking about artificial intelligence at Johns Hopkins, because they're doing great things. They're doing some fantastic things. Dr. Saria, she's a professor in the computer science department, and you can see she's working on septic shock. She's created algorithms that help clinicians, physicians, and healthcare professionals understand how to identify it early enough so that it never causes the patient any problem. We've got, the co-founder, Ms. Riley, who of Drive AI. She is an alum from Johns Hopkins, and she's focused on self-driving cars. And you can't imagine who she might be partnered with, can you? And then lastly, Dr. Bell. Dr. Bell, a biomedical engineer and assistant professor here at the university, is dealing with ultrasound photoacoustic biomedical scans and helping to clear out the noise, articulate how we might approach image processing for these kinds of problems. And we're very excited about the work that's going on at Johns Hopkins. They have identified and created a curriculum that is world-class. So great to see that. They're taking advantage of a situation that people in government are experiencing, and this is it. We have a situation where today data is exploding at a rate that is impossible for government agencies to figure out how to consume in a way that drives insight for their missions. And you can take any one of these examples, like the National Institute for Health. They have 21 million publications and more than 2.5 petabytes of genomic data, and soon they will have, billions and billions of DNA signatures and profiles in their gene bank. You take a look at the Department of Energy. They're using 300 terabytes of data from light sources every day. And generally speaking, a citizen in the United States generates about 2.7 terabytes of data, just walking around, living their lives. So it's causing government to rethink how they're going to deal with storage, processing, and analytics associated with that data. And they're understanding this concept of a virtuous data cycle, where the more data they have in storage in the cloud via their cloud strategy and their digital transformation strategies, the more those things go through networks that are connected to edge devices, and those edge devices, whether they be a Humvee or an International Space Station or a Patriot missile, those things create data, and those data are then stored via network back into the cloud for more analysis. And so this virtuous cycle that the government experiencing is ramping up faster and faster and faster. And we, as government officials and people who support government, are really trying our best to figure out what is it going to take to ensure that these common challenges get dealt with. How do we make evidence-based decisions? And by the way, let me give credit to the NTIS Department of Commerce. This Department of Commerce slide is the one that they're using. They've created a new business model for the acquisition of data science strategies for the US government. That strategy is to create a series of joint venture partners in the data science community. And this slide is what they use in the Department of Commerce to sell their services to all federal agencies. And they've created this list of data challenges that the government is experiencing. And if you're in government, you're likely experiencing them too. Now, of course, the solution framework involves all these things over here, on your right, all these things that we call data science. Now, you've heard us talk about several terms, and I'm going to try and quantify and give you a taxonomy around these terms later, but needless to say, the federal government is facing data challenges that are not easy to overcome. That's one of the reasons why they created these plans. You're probably familiar with them. The first one that came out was in May of 2016. If you're not familiar with them, don't look at the White House website because they're not there anymore. I do have a link to show you where the AI plan is. These 7 strategies, they talk about what it takes for the government to deal with this explosion of data. And you can see there's some real issues here. You know, how do we develop new techniques? How do we deal with trustworthiness of data? Understanding of privacy, ethics, and security. And then, you know, improving big data education. I was talking to Florence from NASA, and she helped me to appreciate there is just a new Stanford AI Index report that came out, and it reinforces this gap that we have in government across all the United States, which is, you know, we don't have people who are competent in the data science capabilities so that we can hire them in government so that they can help us deal with all this data. That's one of the reasons why we're extremely proud of the work that's going on at Johns Hopkins, because, you know, they have a great data science curriculum, and they're creating the future workforce that the government and the rest of us can take full advantage of. The other strategy, a strategic set of documents that came out with this, is preparing for AI, and then the R&D strategic plan for AI. And you can see the links there. They added some additional components that the big data plan didn't have. Specifically, they added an objective targeting this idea of creation of standards. And today, that's one of the gaps that we have. We don't have a lot of standards when it comes to how we're going to deal with data and how we're going to process data. It also talks more specifically about creating a data-savvy workforce. And if you take a look at almost every RFP that's gone out from the government to industry, one of the most important components of those RFPs is whoever's responding needs to think about how they're going to contribute to the development of a data-savvy workforce in government. And then lastly, there's a significant focus on ethics, privacy, and security. And that's probably no surprise, because the first chief data scientist for the US government, DJ Patel, on his way out, made it fairly clear that he believes that every data scientist, whether they're in government or not, but particularly the ones in government, need to have specialized training in ethics, so they can create and develop a strong moral compass. Because what I can tell you is that if you are a data scientist, you are likely going to be asked to do something, to create an algorithm, or to provide insight in an area that you might find objectionable. So having this idea of ethics inside artificial intelligence strategic plans, especially for government as a steward of citizens' data, is a fairly significant thing. So let's talk about some of the ethical, legal, and societal implications associated with AI. So the first word that everyone jumps to is bias. And while I think there's some real need to be cautious about it, there's one place that I've seen that's quantified it fairly well. My colleague, Kathy O'Neill, you guys have likely read her book. Her book is the, I guess for AI practitioners, the quintessential discussion point focused on the weaponization of data and what she calls the inequality that threatens democracy. The idea that she documents fairly rigorously in the book. And by the way, you should know she's a Harvard-educated professor, and she's a Wall Street analyst. So she has a deep understanding of all of the issues associated with how data works. She's a very significant practitioner. And she goes into some excruciating details about how data science is really threatening the very people who are creating the data that feed it. The other thing that I think I want to bring attention to is the 2 Supreme Court cases that are now on the docket. Now this one is about Timothy Ivory Carpenter. You probably don't know him from Adam. I'm from Detroit, so let me start there. This guy is also from Detroit. Timothy Carter is a thief. He's a thief. I'm not a thief. All people in Detroit are not thieves. But Timothy is a thief. And the police were after him. He kept robbing cell phone stores. Now, the problem with it is that the police decided the best way to catch Timothy was to track him for the next 130 days. And that's what they did. They tracked him using his own cell phone. And then they went to the cell phone providers and asked for all of his data And they were able to pinpoint whether he went to church that day, or where he went to go visit his mom, or whether he went to the store to rob the place. And in fact, they take all this data and they created a case. Now the problem is, first of all, let me say that I am in no way interested in supporting Timothy and his bad habits. The problem is that this is a warrantless search. And I think the reason that people are interested in what the Supreme Court is going to say about this was two reasons. One, this and the next case that you're going to hear about, they were not coming up as a result of anything that had to do with a split. Normally these splits happen at circuit courts, and the splits are then adjudicated by the Supreme Court. But this case and the next case were not taken up by the court as a result of a split. They were taken up because they know that they are going to have some far-reaching impacts. And the question that will be answered by the Supreme Court is whether or not anybody has the ability to take your data and give it to somebody else, whether they're solving a crime or not, without your explicit permission. The other case is one that you likely have heard about, and you've heard about the Microsoft Ireland case that's going to the Supreme Court. This is another non-split decision, and this one really talks about the extension of the United States federal government's data laws into another sovereign nation. What the Circuit Court has argued is that the United States has the ability to extend its legal framework into other countries, so that if I want to use my law to get access to information or data in your country, X, I can extend those laws to your country without your knowing about it and force you to give me the data. And so the Supreme Court is going to take a look at that. Now, these issues sound like they might be isolated, but when it comes to the vast troves of data that we're producing and how they're going to be used, it can be very, very impactful. So we want our children to be highly educated. So we're collecting data about them so that we can find ways to remediate them. Like, you know, my son, he's in the first grade, maybe he doesn't do very well in calculus, so we're going to give him a tutor and we're going to make sure he gets better. Unfortunately, this idea that he's not very good in math, because it is a data point collected, will follow him for the rest of his life. And it might impact his ability to get a nice student application through Johns Hopkins. It might impact his choice in wives and maybe impact his future job. So this is serious. The other area that's important to think about when we talk about the societal implications of AI adoption is the workforce. Now, I just read a report that said 73 million jobs in the US will be impacted by artificial intelligence by the year 2030. And so that's not an insignificant number. And so what many governments, many government agencies, many leaders in government, as well as industry are trying to think about is what really is the impact of automation, internet speed, thinking machines with no lapsing memory. What's the impact of those capabilities on the workforce? And if you consider the differences in the jobs, in the Industrial Revolution to the AI revolution, you can imagine why it's a significant issue, right? Now, for me, I think that we're still in an area where we're going to see advances in automation and we'll see a job shift. But also I know that, if somebody can do my job cheaper anywhere else in the world, my job is at risk. So I'm very pragmatic about it. I think I'd like to come back to Kathy for a minute, because she just published a couple of weeks ago an op-ed in the New York Times. And the reason that that's important is because the ivory tower she's talking about is academia. The ivory tower of academia can no longer ignore artificial intelligence. And in this op-ed, she makes a very strong case that academia has been lacking in its ability to report to government the real implications of adopting artificial intelligence and data science. And so there's some things that are happening that are addressing that now. I'm on the advisory board for the South Big Data Hub that's out of Georgia Tech in Atlanta. And we just created a study about a year ago focused on something called the Data Science digital divide. It's an NSF-funded study, and what it tries to understand is who are the haves and who are the have-nots with respect to data science. Would you be surprised if I told you that of the 117 historical black colleges and universities in our nation, that 0 of them have a data science curriculum or program? Would you be shocked to hear that we do not have data science programs in many majority institutions? If we continue on this track, not only will the government be unable to harness the power of the data that we've talked about that's growing exponentially, but we won't be able to realize all the great benefits that we want to get from data science and artificial intelligence. And so there is some good news and some bad news. We understand the problem and we're very much working on it. And the reason we're working on it is because of these benefits. These benefits, they're not Star Trek anymore. This is not happening, in 2029. This is what's happening right now. We are accelerating large-scale solutions. So when you think about the Collaborative Cancer Cloud, or you think about the National Cancer Initiative, or personalized medicine, immunotherapy, all of these advances are made possible by data science. When we talk about being able to unlock the brain initiative, or uncover new theories, whether they're in quantum physics or others. We're using data science and artificial intelligence to get there. And so, from a real world example, the government is focused in these areas in the yellow at the top. Military operations. I think on Monday, the Washington Post reported that the DoD is going to focus and triple its budget in artificial intelligence. Citizen services, things like transportation, energy, water, will all have automation, thinking machines, real concepts that help serve citizens faster, better, and more efficiently. Cyber intelligence, that's the move from cyber defense to proactive cyber. And then health and life sciences. We're finding health and life sciences, this $50 billion industry in the US, is one of the prime targets in government as well. So how many companies do you think are focused on this idea of changing health and life sciences? How many companies can you think? 20, 40, how about 100? 100 startup companies have already started using data science to change healthcare. Everything from when you get admitted to the hospital, everything about referrals and appointments, if you get moved to any of the sub-disciplines like radiology or surgery or infection and disease control, somebody monitoring the entire patient experience. I mean, I don't spend a lot of time in hospitals, but I can tell you right now, I'm going to start going. Because these people have figured out how to master the idea of the electronic health record and turn it into the change of the experience for the patient. Each one of these startup companies, each one of them, have some idea of how they want to take the data that's coming from the hospital, the patient, the insurance company, the new relationship between insurance companies and pharmacies, to turn all of that into data that can be used to reinvent health and life sciences. And we're hoping, we, meaning Intel, are very hopeful that this translates into something great for the veterans that are as part of the military health system. And we're very much focused on trying to figure out how to do that. Now, again, the question is, why is Intel got a chief data scientist? So, would it surprise you to know that Intel in the last 12 months has spent $1 billion in artificial intelligence? I'm going to show you what we spent it on. But I know most of you think of Intel as, that great company that has the dun-dun-dun, the hardware inside, and we are that company for sure. But you'll see through this talk that we're much different than that. We're also going to describe how we relate to these things called data science, because one of the things we're finding is that some practitioners are trying to use a hammer when it really requires a screwdriver. And so understanding the differences between these four things, which are notionally referred to as data science, is important. So first, data analytics. These are the core analytics. This is where government usually starts its investigation of data science and artificial intelligence. It is the diagnostic, descriptive, predictive, and prescriptive analytics capabilities. They were what happened, why did it happen, what's likely to happen next, and what in the world should I be doing about it. These are the analytics that we're talking about. And Intel's kind of got some tools for that. One of the things that you might be surprised is that Cloudera just purchased Fast Forward Labs. And Fast Forward Labs is an academic company, a research company. And they partner with academicians to build machine learning and cognitive computing tools. But quickly from this core analytics capability is this machine learning and cognitive computing. This is where we are trying to make the way people make decisions. It usually involves two aspects. This idea of training, development of algorithms, and then training them over time. And then inference, the ability to use what's been trained to make a reasonably sound decision. And generally the training component of this is long, and the inference component is short. And there's some tools out there that are associated with that too. Saffron is one of the things that we purchased. It's a machine learning cognitive computing capability, and it's supporting government in ways that people like the Navy and other organizations are using. And then deep learning is this idea of now not taking just these training and inference capabilities, but then going through some convolution or neural network capabilities that heighten the experience in learning. And you may have heard about the Movidius stick, USB stick. It's an Intel product that has convolutional neural networks built inside. You can daisy chain them, and you can use them for image processing on the edge, as well as the acquisition of Nirvana. Artificial intelligence is a little bit different. And in the strictest sense, we've only seen this concept experienced in a very narrow set of circumstances. This idea of narrow artificial intelligence is really what we've been saying when we talk about learning machines. We haven't actually seen a sentient, conscious machine yet. And I'm actually quite concerned that we might, as many other people are. And why? Because these machines learn based on human interaction. And the question we as practitioners need to be asking ourselves is, are humans the best model for this new type of conscious, sentient machine? I'm not sure whether we are or not, but I know that we need to be very, very clear about what it is we're going to do with this training and learning that's based on human behavior. So we have some neuromorphic chips that I'll talk to you a little bit about as well. So Intel's a data company, and if you think about a data company, we might be thinking about many different types of companies like Apple, Facebook, and Google. And what I tried to show here is a sense of what those companies are doing with respect to their investments and acquisitions from 2012 to 2017. When you take a look at that, you'll see some really great companies, many of whom Intel partners with. But just look at the bottom row, and I'll kind of blow that up for you. This is the set of companies that Intel's been spending $1 billion on. And what you'll see, and I think the thing that you ought to be thinking about is that these 27 companies that are now in my portfolio for data science, they're software companies. They're software companies. They invite us to harness the power of data science by marrying advanced silicon architectures with customized code and workloads. And it's like blazing a stick of dynamite. It's really not fair to compare us to other silicon providers because those providers don't have the benefit of having advanced software that marries directly to our silicon architectures that accelerates learning, inference, training, and the insight that we're trying to get to from artificial intelligence. These are the challenges that we're focused on, and you probably can see some of the same challenges in your government agency or your location as well. Things like, it's still very much an art, tuning the algorithms and changing the levers to get better probabilistic insight. And when you have multiple hundreds of terabytes of data, that can be tricky. course, the idea of the complexity of data. As a scientist, we're seeing 2D, 3D, 4D, unstructured, structured, video and image, every type of data that you can imagine, and the density of that data and its complexity is getting more and more difficult to deal with. And then the hard blocking and tackling is what I call it, of getting the metadata associated with the data, right? So like, I guess 4 years ago, it was determined that the metadata associated with data has outstripped the amount of data. And so, when you don't have data classified and you can't ascribe some sort of schema or metadata tagging or labeling to it, it makes it very difficult to get the insight. So this kind of blocking and tackling is something that I spend a lot of time on. You can see our accelerator portfolio, and most of you guys, since Intel is used in 98% of the clouds and enterprises are using this, you will see that there's on the far right, a discussion around Lake Crest. This is our new ASIC capability along with the Stratix 10. It's an advanced FPGA that's programmable at the end, at the edge. But that would be only half the discussion. Intel is also very much focused on the same kinds of open source software frameworks and languages that you are. And the reason we're doing that is so we can enable you to prototype and implement your solutions much faster. As I mentioned, Nirvana is our deep learning tool. It is a government-funded initiative that we purchased. In-Q-Tel created this company in 2015, and now we bought it. It allows us to do deep learning, and I know that many government agencies are still very much focused on cognitive computing instead of deep learning, but I wanted to show you what kinds of capability we have out there. And the reason it's important is because this software that you can actually download for free from GitHub is married to this chip. This chip in the Crest family is an application-specific integrated circuit which will accelerate both the learning and inference associated with your convolutional neural networks, whether they be at the edge or in the data center. And then we do have this cognitive computing natural language platform called Saffron. It has got one unique differentiation that I want to share with you, and that is that it works more like your associative memory than a traditional cognitive machine. So if I ask Jonathan, he's this really bright PhD student here in the front row. Jonathan, how many times do you have to touch a hot stove before you know that a hot stove is probably not a good idea to touch? We don't need to feed Jonathan 100,000 opportunities to touch a hot stove before he has the inference that's a bad idea. He will probably figure that out in one time. And so the ability to infer at ingest is what this tool does. Inference at ingest is important because if you're trying to get to a very important, very close to real-time decision, creating a learning mechanism that communicates back to the cloud and then come back to the edge with a decision might not be appropriate for you. It might be more appropriate to create an inference insight at the time the ingest is being done, much like Jonathan's brain does. And you'll see this stack has got all the things in it, like a set of open source extractors and connectors, an engine for memory-based reasoning, and a visualization tool. The reason government folks love it is because it will work very closely with all their open source tools as well. I really couldn't talk about artificial intelligence without talking about neuromorphic computing. If you're thinking about neuromorphic computing, it might be interesting. This is a research project that's in Intel Labs. And instead of doing learning in one spot and then inference at another spot, we're doing learning and inference in the exact same chipset. And it's like creating neurons exactly the way our brain creates those neurons and remembering pathways. It has several different applications. High performance computing is one, massive parallel computation requirements are another, and then, this idea of leveraging all of the work we've figured out how to do in mirroring code optimization to specific hardware capabilities to accelerate learning and training. And then lastly, and then I'm going to end, so you think about your questions, because I think this is either the last slide or the second to the last slide. Intel is really focused on quantum computing and qubits. Now, of course, most chips today don't operate traditional CPUs, GPUs, TPUs, or VPUs, operate in a quantum computer, right? The D-Wave has to operate at a negative 180 Kelvin. So you're not going to run any traditional chip in there. But Intel's focused on a $50 million quantum investment where we're using ultra-pure silicon that will allow it to operate in this kind of environment so that we can deal with decoherence and superposition as part of a qubit strategy. So if you're interested in that, I can talk to you more about how to get access to that and how to participate in that. Because in this case, we're trying to understand what the right questions are as opposed to what the answers might be. So when you think about this virtuous data cycle, not only does it represent the virtuous data cycle that the government is experiencing, that came out really bad, but it also, in fact, represents Intel's strategy around data science and artificial intelligence. Actually, it represents Intel's corporate strategy as well. You'll see it described as the virtuous cycle of growth. It's the reason why Intel is spending so much money on data science, because we're not treating data as the exhaust part of the equation anymore. We're treating data as the fuel part of the equation. And that is because our customers, our government customers like you, are determined to do the same. If you're treating data as the exhaust portion, I would encourage you to think more seriously about this virtuous cycle of growth, and then take a look at some of the things that we talked about in terms of solutions that we can make available. So that is the end of my discussion, and I am open to taking some questions.
So let me start things off and then see whether or not other audience members have some as well. I wonder whether or not maybe you could give us examples of what you see perhaps as an example of best success of actual use of AI in government, and then maybe a counterexample of a potential bad outcome.
Yeah.
Maybe bad outcome ethically or bad outcome otherwise, just kind of the wrong prediction, for example.
Yeah, so I want to talk about the successes in two very different ways, because one is technical. So we've seen some really great successes in health and life sciences. When we take a look at what the Department of the National Institutes of Health are doing, they've created a number of initiatives in their BD2K, their Big Data to Knowledge initiative. And it is significantly advancing all of the work in genomics, biometrics, and personalized medicine. It's having a material impact on the way research is being done at NIH. So that's a really great thing. On the business model side, I want to point back to the Department of Commerce and their NTIS activity. Today, many agencies are still operating in an environment that is more like the traditional FAR environment. The business model that the Department of Commerce is uniquely, by the way, positioned to offer is one where they can, in roughly 60 to 90 days, with joint venture partners, go from ideation to an awarded solution to a government agency. And I think one of the key differentiators, other than speed, is that the government doesn't come to industry with a known problem. There's actually a thing called a whiteboarding session, and industry sits with government agencies to define and redefine what the answer might be. And so I think these two examples highlight really good ways the government is utilizing its tools to get access to and then apply data science. Now, in terms of something bad, I'm really not in position to talk about too many bad things, because we're still very much in a nascent environment around the application of data science in government. But what I will say is we've seen some things that were unexpected that weren't necessarily part of government. I had a conversation about how chatbots have become xenophobic, racist environments. We've seen, as I talked about, this idea of weaponization of data, both in terms of segregation of voting rights, activities associated with and access to financial services and financial tools, and of course, I mentioned education. So there are areas where we need to be very cautious, and I think the lessons that we have learned are that we need to do a much better job of testing and evaluating algorithms. I think the core message that came out of Kathy's op-ed is especially academia has an opportunity to discuss in a more open fashion with government what these challenges really look like. Because sometimes, you might think if you're in academia or in government or in a court or in law enforcement, if the machine said it's right, it must be right. That's how we treat lots of things. But in this particular case, we need to be very more careful. And I think one of the challenges is opening up the algorithms and seeing what's really inside. Yes?
So, following that, what do you think? I don't know if anyone of you have seen the Black Mirror episode.
Everyone talks to me about this.
China.
I don't have Netflix,
But they're implementing it now, right?
Yeah,
China is doing this,
Yeah.
right? I mean, it's not China. This was the Black Mirror that forecasted the Chinese policies. What do you think of that?
What do I think about it? I mean, I think it's one alternative. It's interesting. When you take a look at movies or entertainment, there's only been one movie where artificial intelligence worked out well for the humans. Only one. And if you can think of that one movie, I'll give you a gold star. But there's only one movie. All the other ones, Ex Machina, The Terminator, HAL, every movie where data science has been represented, the humans didn't fare very well, except in one movie. Do you know what it is?
Will Smith movie? Will Smith movie?
No, iRobot? No, didn't work out too good for the humans. No, the movie that I'm talking about is Big Hero 6. Big Hero 6. Right, so this is a sentient thinking machine, and it worked out great for the humans. But I think that it only reinforces our need to be very careful.
I'll start my
Okay.
So, with respect to the two cases, the Carpenter case and the Microsoft case, without going into details, they really came about because you were trying to apply a legal construct from decades ago to technological capability today. So, and everyone has accepted that technology is going to go way faster than the law, which is going to cause us more and more problems.
Unless we apply artificial intelligence to the law.
Well, a different issue, but
Right,
in
okay.
terms of making the laws.
Oh, right. You're
Right now, we've got a Congress
Yep.
that has almost no competency whatsoever in science. I mean, maybe since John Sununu retired, I don't think we've had, no, I'm not, this is alarming and terrifying that you have folks who don't understand the way science or even respect science, much less data science and the application. So what are we going to do to educate and to make sure that we have that level of competency so we have the right laws happening so that we can address these issues of bias and weaponization of information and the fact that you can't get transparency into the algorithms. And if the EEOC wants to find out whether an organization has been discriminating, they're going to have the ability through the law to get to the specifics in the data that are going to show what happened in a particular organization to hold them to account.
Yeah.
So what do you
So
think
this is a
about
great
the
question. I
education?
think there are three things we can talk about. The first and probably most significant is that other countries are adopting legal frameworks that are more modern. So when we think about the GDPR being implemented next year, we talked a little bit about that in May, that's going to demonstrate what a real modern law around personal privacy and data protection looks like. And so that will have some impact. I think second,
When you say GDPR Germany, yes?
pardon me?
GDPR Germany, yes?
No.
No,
sorry.
GDPR is EU-wide.
Okay, I
I'm sorry.
apologize.
So-
I just want to make clear for people who are
the
interested.
General Data Protection Regulation is what I'm talking about. Actually, the regulation was developed a pan-European about 3 years ago and helped me keep my dates straight. And now it's actually going to take effect as a formal law. And it has, I think, 12 basic principles, things like you have to ensure that you get explicit permission to use someone's data. You can't use data for any other purpose other than the purpose for which it was collected. You must maintain the privacy and confidentiality of data. So there are a whole host of things, and the punishment is very real. It is 4% of global revenue for any company who violates them. So these examples, I think you'll see the Asia-Pac region adopt a similar GDPR framework, and of course the Canadian government has already got 2 data privacy protection laws that are very much like the GDPR. So these examples will certainly shape our administration. Second, and probably as impactful, if not more, is that legislators are starting to feel what it feels like when their privacy is being violated. So when we have senators whose servers are being surveilled by intelligence agencies, and they are on the Intelligence Committee, then this brings home the issue associated with what's really reasonable and from a privacy and search perspective. Less optimistic is that the general public will become more aware of the implications of use of their data. I think we have come to a situation where people are kind of used to trading this privacy for convenience. And so in many ways, you know, your ancestors in Germany and folks who lived in Europe, they have a keen understanding of what it feels like when somebody takes data that is supposed to be private and uses it for a purpose other than what it was intended. So while I'm not as optimistic about the third one, I think the first 2 will have a material impact. Then lastly, the article that Kathy wrote around academia, I think the call to action is academicians really ought to step up. Now, full disclosure, I'm in the American Association for the Advancement of Science. I'm in the National Academy of Science, and I will tell you that we spend a lot of time wondering what we ought to be doing, and I think now is our time to, in spite of this lack of appreciation for the contribution of scientists, to start having a more meaningful conversation about what we need to do.
So, Melvin, I took a kind of an informal poll before this session began this morning, and there are a number of folks here who are saying, you know, I'm not sure what my agency would do with artificial intelligence. You know, there are any variety of problems. I'm not sure I could pinpoint one. And so the question is, if an agency kind of wants to stick its toe in, but doesn't have $1 billion to invest, is there a way they can kind of stick their toe in and try it out a little bit to see?
Absolutely. I'm really excited that you asked that question, because these are exactly the kinds of issues that the NTIS is focused on. And I want to share with you what they commonly refer to as challenges that agencies are dealing with. This is the stick your foot in the toe of the discussion. So, you know, things like transparency and accountability. All our federal agencies have some record manager who's responsible for collecting and managing the records in that agency. And so now the question becomes, is there a way with shrinking budgets and increasing missions that data can be used to more efficiently deliver services? So it might be that you're in the Department of Transportation. Dan Morgan, who's the Chief Data Officer there, is really focused on figuring out how we can use all the traffic data to make better sense of how to develop and invest in core infrastructure for roads and other things in transportation. And CMS, we're seeing examples of where they're using all their data for fraud, waste, and abuse. How can we ensure that these claims aren't paid more than once? How can we make sure that the prescriptions are actually to the right person? What do we need to do to ensure that we're getting the best use of our dollars in supporting healthcare? One of the really good examples that we're seeing where this is happening is with HHS and the opioid problem that the country is facing. And one of the things that they did is they noted that the problem was real. And then instead of just having people in medicine, biomedical engineering, and pharmacology work on this problem, they really assigned it to 44 data scientists. And these data scientists are now evaluating the vast troves of data that HHS has to figure out how they can identify pre-triggers to this addiction problem. What are the remediations that work? How can we institute them faster? We're doing the same thing with Alzheimer's, but these are the things that get your toe in the water. And you can operate with any number of companies. Intel partners with all of them. Or you can come and talk to me or any other Intel person directly, because one of the key things that I do is I actually sit down with agencies and help them craft early stage prototypes that they can use to test out what you might see as a reasonable objective in data science and artificial intelligence. It doesn't cost billions of dollars, and it starts off with an understanding and development of a use case, and that use case then shapes what it is that we're going to prototype. And generally speaking, we can arrive at a reasonably sound understanding of what your first step might be in a short period of time, using most of the tools that I talked to you about. Yes, sir.
Are there particular attributes of data sets that are more likely to deliver useful results using, say, machine learning or data analytic methodologies?
Yeah, so the best case scenario would be some structured and unstructured data that is already labeled and classified. The problem is very few of those exist. Right? So we're talking about a situation where most of these large data sets don't have a classification or labeling associated with them. And so what we tend to end up having to do is to create mechanisms or tools to harmoniously understand the data. This is the blocking and tackling that I talked about earlier. But if you happen to have something like that, they are the prime places to start. And they operate in different domains. I think the domain that we spend and see a lot of time in, we talked about earlier, is health and life sciences. So genomics, biometric data is really easy and good. Now that the Human Genome Project has given us a sense of what those are, we can use those as a base to start establishing things like anomalies, mutations. We can understand how to use CRISPR and Cas9 in an accelerated fashion for synthetic biology. Other areas are things like military operations and military data. These they tend to be fairly structured and very easy to ingest. These are the kinds of data sets that are pretty good to start with. On the civilian side, things that are already codified help as well.
What sort of time frames, historical time frames, can support that?
Yeah, so I think it's difficult to say because size matters, right? So if you're dealing with a single unit of data and it's 100 terabytes or less, we can probably come up with some kind of estimates based on the type of data. But again, what Intel's story would be is if you're using a general purpose processor for ingest, analysis, training, and then inference, it's certainly going to take longer. What we're being strong advocates of is taking your data set and marrying it to a silicon architecture that's specifically designed for that data set. I hope I answered your question, but I mean, it's very difficult to give you an estimate without size. Yes, ma'am, Dr. Lawrence.
So one thing that NASA does is we send stuff to different planets and places that precludes us from communicating directly to the craft because of distance, and the one-way light time is just way too long to be practical for a man in the loop. So what I'm interested in, and again, I came here solely for very, very selfish reasons, which is to poke at what I can get from you specifically and the community, and I am looking into how we can use autonomy in very specific ways. One thing that happens is you have to look at the environment with which the craft is in, and we have other challenges that is, failure is not an option, so risk is always something that we grapple with. So I'm thinking along these lines where data science, well, is well and good. Never been to Europa, would like to go there, want to move around, go find life, are we alone type thing. So what I want to know is, how you can help with this application in particular, given the constraints I've given you.
Yes.
And I know this is a long conversation, but just,
Well, no, I think
I
it's
just want to
very-
bring this out because there's a group here, right? So,
Because increasingly government is trying to move the decision point to the edge. And so the question you're asking is related to a very much larger architectural question, which is, if I don't have the ability to move all this data to a high-powered data center in the cloud, how do I deal with these data science tools? And, of course, one of the things we're focused on, and what I spend a lot of time on, is building architectures that allow us to move the data to the analytics in much the same way as your probe would in Europa. We're doing the exact same thing with autonomous vehicles, though, because we don't have the ability to go back to a data set. When we build autonomous vehicles with BMW and Toyota, that's a rolling data set in exactly the same way as a probe or interplanetary device would be. And so in that case, we're using tools like deep learning, like Nirvana. And Nirvana is this deep learning tool that I told you that has built-in set of convolutional neural networks that allow for inference and ingest with speed based on the use of an ASIC chip. I would really like to get you in touch with our folks from Movidius so that you can test out this USB stick. It comes with convolutional neural networks and deep learning that allows you to ramp up and learn in ways at the edge that we haven't been able to show before. And then this new Lohihi, a neuromorphic chip, is really, really important. You have no mechanism to go back to Earth for the retransmission, verification of the data, and then actuation of a probe. So we need to have learning at the neuromorphic edge. And this chip was the one that can provide it. So what I think I'd like to do is give you a sense of how our deep learning strategies and our neuromorphic strategies might be able to help NASA. I will tell you this, they're definitely in the research phase. And so this is an opportunity, and this is the other thing that differentiates us. You don't have to wait until we've finished building something to get access to it. If you want to participate in this roadmap development and design, this is the great time to do it. And I'm definitely the person that can help you get there. So the short answer is these are kinds of tools. I don't have the exact answer, but working with you, we can get there. Yes, sir.
Sorry.
Oh,
I was going to say, may I ask a question of the audience in general? About 2/3 of you are from government agencies. How many of your agencies are currently using AI? Just by show of hands. I see 2 hands, maybe 3, not too many.
maybe automation,
Well, how
not
about
augmented, not
the
AI.
use of? Try that question.
And let me deduce by the fact that you're all here, many of you are interested or have hopes. And let me further ask, do you know what business use case or why you want to use it? How many know why they want to use AI? So a few more, 4 or 5 hands. So let me draw out something that Melvin said earlier and ask Melvin a question and kind of ask you all at the same time as well. One of the things Melvin suggested earlier as well, an agency that maybe is interested but is not sure how it wants to use AI could invite one of these hundreds of companies or perhaps many of these hundreds of companies in to say, help us frame the problem we want to solve. Don't just help us solve the problem in a traditional proposal, but help us think in an early stage about what the problem is. And of course, you may get lots of different answers. So then let me ask, have any of your agencies tried that? Kind of asking and inviting the community in to help you frame the problem. Again, show of hands. So again, relatively few are doing that. And let me ask you, Melvin, how important is that? Because again, to me, at least personally, and my company is involved in analytics and some facets of AI, it's confusing to me in many ways. I'm not sure what all the business cases are beyond some really specific ones I'm working on with some really specific clients. But how important is it to get that kind of wide range of input into what the business use cases are?
But Jeff, you've asked a really important question, and I want to answer these use case questions quickly. But I'd like to ask one more question. How many people in their agencies are experiencing this problem? Yeah. So the fact is that agencies, almost all agencies across the board, are experiencing this data problem. And so the use case is really mission specific, right? So if we take a look at, let's just pick one, the National Atmospheric and NOAA, right? The use cases that we see from NOAA revolve around climate change, climate management, understanding weather. They've understood now that almost every 21 days there's a natural disaster somewhere in this country. And the question becomes, how can we predict them better? What's the rationale or source of these? And what ought we be doing about it from a policy perspective? That's the kind of use case that we would expect to see from NOAA. The same thing if we look at the Department of Energy. We have many, many, many more sources of energy. There are many, many more ways of distributing energy and consuming. We have many, many, many more data centers which are now consuming more and more of that energy. And so for the Department of Energy, the question is, how do I use high-performance computing and hyperscale to help me partition the kinds of energy that need to go where? How do I use new battery technology and solar technology to administer and redistribute how energy is actually consumed? And so each use case at an agency tends to be very mission specific, but it is driven by this one factor. And this factor is undeniable. I could have picked any agencies, every agency. And if you don't believe me, let me ask you this personally. In your own personal life, on your own personal laptop, how many of you are being overwhelmed by the data that's on your own personal devices? I can't find anything anymore. If I don't label it or put it in the folder that it's supposed to go in, you know where it ends up? On my desktop, from which I then do a global search. But this is only going to get worse. You can see I've projected it out to 2020. And the farther out you go, the worse the problem gets. Jonathan.
So for the process of doing data science, you need to gather the data, label it and clean it into a format that can then be stored into processing power. I'm interested in the question of whether for government data sets like this we don't want to be redesigning and rebuilding data every 10 or 20 years, whether there's a question of what the best storage formats are, how you get to labeling, and whether there are formats we should be looking at that are effective at being analysed by current day silicon, next gen silicon, or whether we're going to be having this conversation every 5 years of what you need to do to your data to make it analysable in today's world.
Yeah, so Jonathan's question is, do we have standards that help drive how data ought to be stored, labeled, and accessible? Nope. We don't. This is one of the problems. This is the reason why that R&D Strategic Plan for Artificial Intelligence asked us to think very seriously about creating standards around data classification and storage and search, because we don't have good things for that.
And
Yes.
the agency records officers, and in some instances they're statutory, have the requirement, and mostly from a construct decades earlier in the paper world, to make sure that the records of the organization are properly managed, and then at some point, depending on the value of them, accession to NARA in a particular way, and NARA's been now talking about it being solely in electronic forms by 2020. How do you reconcile the notion that an agency has their records management infrastructure set up to meet the National Archives requirements, and some of that is data? It's not records.
So I think the thing that's most interesting is that the government has realized this problem, and that's the reason why they've mandated now every agency have a chief data officer. There are 40 chief data officers that are in the agencies. They sit in a data cabinet, and that data cabinet wrestles with these very issues, like how do we reconcile the data classification requirements with records management requirements? How do we make use of this data? Where are we going to store it? How are we going to take advantage of it? And we've engaged many of these chief data officers that are part of the federal data cabinet, help them understand what we think might be best in class. But the government is still working through that very issue. Yes.
You started your session talking about the importance of ethics, and I don't think ethics are changeable, but perhaps implementation changes from time to time. So understanding that certainly one way of dealing with things ethically is also to have laws, but if there are not laws, are there other guardrails that we as data users and data consumers, are there other things that we can do to act ethically if there are not laws in America related to protecting some of these things?
Yeah, unfortunately, I'm a data scientist, right? So I don't have the benefit of being a social economist or a priest.
Well, but you did talk about it being important, so...
No, but what I mean by being important is that we need to think seriously about how the algorithms and data science capabilities we build can be used, right? So, what we don't want to be is in a situation like the movie, right, where we build something and then somebody takes it and turns it into something that's really bad. What we want to really do is we want to think reasonably sound and thoroughly around what the implications are of what we do. And I think that's where we start. Absent of a moral judgment, I think that we just need to do a better job of communicating what we think is the right thing as a society. And again, these are the kinds of discussions that Kathy was being an advocate of happening in academia. Because this is the place where we can actually get some real thought around why things are the way they are. Why is it that we have people who are providing these huge amounts of data and at the very same time that are not benefiting from the output of the analysis and the insights derived from that data? And I'm not sure I have a really good answer for you. I kind of stay focused on creating the benefit side of it.
I have to say there's a kind of a glaring thing to draw together here as well. So from REI's experience working with big data and analytics, we think the government, of course, has access by its power to compel to data for a lot of different people that's very private and concerning if it were exposed. And at the same time, we look at Equifax. Well, if all that data had not been aggregated together and been used for analytic purposes that were quite valuable, it would not have been easy for kind of one cyber hack to get in and steal it and make these bad uses of it. And I think the same is true, perhaps even more significantly with government, as we gather the data together in ways that we can use it for analytics that have quite valuable benefits. We also face the risk of, Jesse James robbed the banks because that's where the money was. People will rob the data from the government because that's where the data is. And I think that's something that, is partly an ethical issue, but it's clearly also a security issue. We have two more questions. One, ma'am, and then I have one for you all, and then we'll wrap up.
Okay. I work at the VA, and we are modernizing lots of systems and in our strategic plan trying to anticipate technologies like AI that are coming up, because we have a workforce that has been trained and has worked in older technologies. So I'm interested in what I can do for that workforce to help them transition or identify new areas that they should be interested in, like AI. Do you have any good suggestions for how to do that?
Yes. So, I've actually had a chance to talk to Congressman Rowe, who is the chairman of the VA, and have had an extended discussion around the hybrid cloud strategy that's being developed, and the cloud broker strategy is being developed there. And the goal of these discussions is to infuse this idea of data science into the decision-making that's going on around veterans' health, especially as it relates to the use of the electronic health record. The easiest thing I can do is point you to intel.com/AI. It has a series of videos and courses and curriculum that we have developed that will jumpstart your ability to understand what we mean by data science and how to start accelerating your understanding of data science for your particular area. We use it for the roughly 1,000 universities that we partner with around the world, but we also make it available to government agencies as they look to establish a data-savvy workforce. And you'll see representatives of all the things that I showed you: core analytics, cognitive computing, machine learning, deep learning, and discussion on artificial intelligence. But I will tell you this, and I'm not a salesperson for Johns Hopkins, but they have a great data science course that will get you started in this discussion to help you appreciate, and it's online and it's easy to get to. So I would start there. And because once you get a significant foundation on what it is you're trying to achieve, then I think Jeff's question has become much more relevant. Now I understand what these things are. How do I use it to move my mission forward? And then from there, come and talk to me and have more ideas.
Thank you.
You had a question?
One last question? No. Okay, I'm going to cold call a friend, Earl Warrington, for a couple of reasons. One is he knows quite a bit about procurement. Second is he was one of the few folks who raised their hands in terms of using AI right now. He works at GSA. And so my question for you, Earl, on behalf of kind of the room as a whole is, there are occasionally, for development of software, the government will sponsor a competition, a hackathon, and they'll just put up a prize and say, of all the graduate students or companies or individuals that come in, maybe 30 will come in over a weekend, and if you solve this problem, the first person who solves the problem best gets $10,000, the second person gets $1,000, and the rest of you, thanks, I hope you had fun. So my question is whether or not, Earl, would it work for similarly with my kind of topic earlier of trying to kind of frame the business use case? Would it make sense and would it be permissible in a federal procurement environment to try and have an agency, let's say one of the ones represented here, NASA or VA or SEC, host a kind of a hackathon to say, help us come up with what would be the most important problem, best problem to tackle using artificial intelligence, so that, again, people who are kind of not quite out of the starting gate as you've gotten past might be able to kind of think about, well, what's the best direction to head out of the starting gate, given their data, their mission. Would that work, Earl?
To answer the question, yes. Can everybody hear me?
Yes.
Speaking loud enough, okay. Somehow reason my ears are clogged. To answer your question, yes. We have done those types of bounty programs, and GSA will continue to do those types of bounty programs as they come up. Right now, we're exploring things in blockchain and other areas as well. The area that we are actually really working in, obviously, has to do with smart contracts. And how artificial intelligence influences the specific smart contracts, the rules engines that are associated to that, the boundaries that are associated to that. So we've actually put, in one area, we actually did a small proof of concept in that area. So we are using some level of artificial intelligence within our organizations. The current technology TTS group, the new group that we have within the General Service Administration, performing certain innovative pieces, they are actually experimenting in this particular area. And we are overall, from a mission standpoint, we're taking a look at artificial intelligence right now in any number of avenues, including robotic coding, and seeing how all this stuff will play and actually help out other agencies as we move forward into the next round of what the internet or the business of government can be.
Yeah, and let me just say this, Jeff. I was remiss by not talking about 18F and what the work that the GSA are doing. They have been, for a while, very much at the forefront, and they've understood the need to get industry in a collaborative sense with government. But if you go to challenges.gov right now, you will see challenges from NASA, SSA, GSA, the Department of Defense. All of these agencies currently have challenges out there right now focused in this area. And this new business model we described, I mentioned the way that the NTIS Department of Commerce is doing it, but I go to meetups downtown every quarter, and there's lots of government people there that are running hackathons and meetup challenges, and they are working at every angle to try and find a way to get more industry infusion into the problem definition as opposed to just respond to a contract. So I think your point is very, very valid.
Jeff, one is it's true that challenges that is doing all this stuff. And it's TSA's product that's doing that, and I agree with that. The key to this is the government is throwing out an idea. government does not have all the ideas. So really, when we start thinking out of the box, we really need to have the community of interest acting as a disruptor to throw at that idea. And so initially, we're throwing out ideas, but then the next step of this is, we migrated the challenges again, is the community has to help us formulate that idea. And not the fact that I may come up with what's a plastic cup and throw it out there on the challenges. I don't have all the answers. I'm looking at these data throwouts right here with the US government explosion piece. And we all know data is cheap until it becomes real data. And so the problem we have right now is over time is not only is it the speed to get the information and make good decisions, but it's really at the end of the day, how do we house all this data? Do we really want to house all this data, or does the internet become the data house? So really, you know, traditional databases be damned, we've got to come up with brand new ways of actually dealing with this whole mess. And I call it a good mess, not a bad mess. But that requires us all to think way out of the box on some of this stuff.
Let me illustrate to close and then turn it over to Kathy. I really would like you all to use each other as resources, whether it be here in the room or if you say, you know, I met somebody from such and such an agency. Jeff, can you help me find them? I'll help you find them. We have your registration information. But this is a great example where one of your colleagues at GSA, he serves and works with a number of other agencies, of course, but nevertheless, he's got some experience that might be helpful to others of you. So I hope that if Earl doesn't mind, I'll invite you to talk to Earl if you'd like to learn more about that. But thank you all very much, and especially thank you, Dr. Greer.
Thank you.
All right, thank you all. Token of our appreciation, so thank you so much for joining us.
Under the government.
Yes, I'm sure it is, yes, I'm
Okay.
sure it is. Okay, thank you, everyone.